In this video, we're going to go over the individual data project practice homework. And in this homework, our goal is to prepare for a data analysis project, final project, with a data set of your choice. But before we go down that path, we want to practice the same set of basic skills on one data set to give us some understanding of what's involved. So in this case, the research question we're asking is, how do students in Python compare from a prior semester? So we have some data. It's linked here. It's a CSV file. You can open it in Excel or in Google Sheets, whatever you have available to you. And we want to analyze this data to output the mean, median, and standard deviation for two data sets that are here. You can see we've got some fall and some spring 2016 data. And to check your work, for example, down here, I calculated the average of fall and spring simply on this sheet so that I could test myself and figure out if I had the right correct numbers. Okay, so our job is to write a program that reads in the CSV file in Python and outputs the mean, median, and standard deviation for the fall and spring semesters. And our goal is to write at least two functions in our final solution, hopefully so we can reuse them in the future. So to get started, our first task is to read in the data file and just simply print it out and make sure that we can do that. So this is the data project practice. I always like to start off my programs with some comments. And I'm pretty sure we're going to need an import, but we'll get to that later. I think to get the mean, median, and standard deviation, we're going to want to take advantage of some built-in Python functions. Okay, so first step is let's just read in the file. Okay, so we have a CSV file, and it is called samplegrades.csv. Now, I need this file to actually show up in the same folder where I'm writing my code. Let's see, I'm getting an error here. Oops, sorry, switching languages. There we go. I was in Perl land earlier today, so I have to make the switch to Python. Okay, so I've created the file, but it's not going to work unless my file actually is there. So I know my file is here, and now this isn't going to work anymore because I'm going to drag this and my Excel file is going to probably get mad at me. So where I want the data file is in the same folder as my Python project. Okay, I want to move it. Hopefully it moves it. Okay, awesome. So that should work. And I can see my file moved. Hopefully Excel doesn't get too angry now that the file has moved. Sometimes it does. Now, if you go back to the file, writing, and dictionary module on the course webpage or lesson, there is an example worksheet called Reading and Writing File Examples, and there's a really great example for opening and reading in each line of the file and just simply printing it out. So that's the example that I'm following right now. So I'm going to say file equals open, and actually I don't need quotes, I'm just going to say CSV, and then for line in file, print line, and then a really important step is to close the file at the end. There's two reasons that we want to close the file at the end. Will your program work without this line? Yes, absolutely. However, it's a really good practice because you may come across a program in the future where it won't work if you forget this line. So there's two good reasons. One is most programs are limited in the number of files that they can have open at any one time. I think you're limited to about 255. So you want to make sure you close all your files because you don't want to leave them hanging open. The other reason is if you want to open and work with that file again later on in the program, you won't be able to do so without first closing it. It'll be stuck at the end of the last thing you've read. So it's just a really good habit to get into. When you open a file, you close it. Okay. So we're reading in the file here. Okay, and let's test it. Let's run this. Because our first step is we want to make sure we're successfully reading in this file. That's it. Full stop. That's what we want to work with. Okay, so let's run practice. All right, and I have an extra blank line between each of my lines. So I'm going to go ahead and use a function that I happen to know called rstrip, which is going to strip any what's called white space. White space are tabs, just blank spaces, or new lines that are on the end of that line. And so the R indicates it's only going to strip white space from the right. Let's see. Oh, good. So now all my lines are right next to each other. So that's good. And so our CSV has three different fields. Okay. So now we successfully opened the file. So I know it's in the right spot. If it says file not found, it means that your Python program and your CSV file aren't in the same location. They do need to be in the same folder for this approach to work. And now that we've got everything like one after the other, we want to start counting frequencies. Now there's two ways that you can do this. You can use a dictionary, or you can simply use an array separated for fall and for spring. But I guess before I do that, I would really like to know how to calculate in Python the standard deviation. So I'm going to Google for Python standard deviation, and hopefully I'll get an example that will tell us Python statistics, standard dev. That sounds promising. So what do I need to import? Let's go see an example. And not only what do I need to import, but what format do I need to put my data in? Does it need to be an array or something? Let's go see. Yes. Syntax. Yes, that's what I want. Data set. So it's probably just a list will work. Data, and iterable with real valued numbers. Xbar is optional. Okay, so we don't need it. Great. Is this in a library or is it built in? Aha, import statistics. Here we go. That's what I'm looking for. Okay. That sounds promising. Okay, so it looks like I'm going to need an array. And then here we have an example. Statistics.standarddev. Okay, so I'm going to create data variables. I'm going to create an array for the spring and for the fall. Okay. Nope, thank you. All right. Yeah, okay. We'll make this work. All right. So if I'm recalling correctly, initializing an array in Python, that looks like a tuple. We'll give it a shot, and we'll go from there. All right. So I need, from this line, I might do some more printing, but for now I'm going to comment it out. Oops. Okay. What I'd like to do is split this line. And I'm going to get it into an array or a list. Call the list equals line dot rstrip dot split should take care of it. And we want to split on commas. And now I'm going to print the list. So what I'm doing is I'm going to step by step build this loop, but printing the whole time to make sure I'm getting exactly what I want, so that if I have an error, I know it's only in this line, and that's the only place it is. Good. So did we successfully do this? Yes. So I have the name, I have the, whether it's spring or fall. And then I've got the number. I will need to convert that number. Okay. All right. So we've got our list. And so now what I want to say is if list 1, right? So the name is index 0. The semester is index 2. Excuse me, 1. And then finally, this is index 2. So if list equals, no, I think you can use equals with strings. And so I'm going to just literally copy and paste this, spring 2016. Then what I'm going to say is spring dot append. Nope. Okay, these must not be initialized to arrays. Let's try square braces. I think parentheses might be tuples. Aha, there's append. That's what I'd like. All right, so spring dot append, and I'm going to say list 2. Now remembering that it's a string, so I'm going to throw the eval function in here because I read this data in from a file, and I can see that these apostrophes, these quotes around this value indicate that it is in the string form because anything we read in from a file is in fact a string. Okay, so I'm going to try this out, and then otherwise I'm going to simply append to the fall. And I'm going to use the same idea of eval list 2. Now, there is a more elegant solution with dictionaries, but for now, I'm trying to follow the most simple solution that I can think of. Okay, now we need a way to test this. At the end, I'm going to simply print out spring, and we'll print out the spring array, and we'll do the same for the fall. Make sure we're getting it all. Okay, let's go for this. Okay, and now this is where I need my data file. Because I have appended each value, I can actually look at this sheet and make sure that the numbers line up. And in fact, because I really like my output to line up nicely, I'm going to just rerun that. Okay, and so what I can see in spring, the first spring value in my file is on line 7. I've got 71, 76, 87. Good. 71. Good. These values are all looking promising. And for fall, 100, 87, 77, 80, 75. Yeah, this looks correct. The final check will be if my numbers actually match up the display that's in the sample output that's in the homework description, the assignment description here. Okay. So now let's try, now that we've confirmed that we've read in the data correctly and split it up into 2 separate lists, let's actually try and print out something that looks like this table a little bit here. Okay, so we're going to have, I'm going to have to print out, I'll just start off here, fall 2016. Let's see. It doesn't say it must be a table. So I will go ahead and just print one after the other. Okay. With a blank line in between them just to keep life simple. Okay. So let's try to print out just the means for each one. And then we can figure out how to make functions. Okay. So the mean, hopefully, will be statistics dot their mean. Let's try fall. And we're going to do the same thing for the spring to really check to make sure we have this. And see, I notice I'm copying and pasting. This could be a great place to insert a function. But let's get it working first. Uh-oh. I get the same number. That's not right. And when I look back, I can see, oops. When I copied and pasted, I only replaced spring once in the output. And so this is the very reason why we want to avoid copying and pasting, because errors are so easy to happen. Okay, let's try this again. Good. Awesome. So I can see that this looks correct. So for now, so because I already had a copy and paste error, I am going to go ahead and make this a function. All right, so why don't we, the function, now I'm looking back up in my program, the function should go right after the imports and before any other lines. So I'm going to say def output statistics. And I'm going to take a list as a parameter. Okay. So I'm going to cut this and put it here. And this is going to be the mean of the list. And I'm going to call the output stats function. Okay, output stats. Oh, but I want fall. And then here, I'm going to do the same thing, and I'm just going to make it output stats spring. Okay. Oops, and file.close. I should really have that moved up higher. I accidentally started typing in between. There we go. Okay, let's run it. Good, and the output shouldn't change, and it doesn't. It still matches what we see for the mean for fall and for spring. Wonderful. So now we don't have to copy and paste anymore. We can go back up to our function and start printing out the other statistics that we want to gather. Median, and you know me, I like everything lined up. Let's see, median, good. Median is a function. Wonderful. It even has median group, so there could be some other analysis tools we have. And you know, let's live dangerously. We'll change 2 lines. All right, standard deviation, space it all out so it matches. This is the one, I think it's stdev. There we go. Okay, let's give this a shot and see what we get. Did we get the right numbers? Yes. It close. Standard deviation is a little different for fall. Not quite sure what happened there. Maybe the file changed with this output, but that looks pretty darn close to what we're looking for. Awesome. So the final step is to create an additional function. And so some candidates could be, you know, reading in the file, for example, and you could append each line to an array. It could be printing the output completely. There's a lot of strong candidates. So I'm going to leave that final step up to you.